first example. All right, we're going to have the lowest priority group going back. The wedge I just drew is going to a methyl group. And then right here we have a ketone. And right here we have chlorine. So the first thing to figure out the configuration of this is that you just examine all of the groups that are attached to the stereocenter. So I guess the first thing I would do is make sure we're dealing with the stereocenter. So you look at this and you can, clearly see there's 4 different groups on the carbon. And then what I want to do, and I always do this first and quickly, is go from the carbon to the very first atom I'm going to hit. So over here there's a carbon. This is a chlorine. And this is a carbon that's going to an oxygen, but it's a carbon. And then we have the lowest priority group, which is the hydrogen. So the Cl is going to be the highest priority here. I'm just going to put a 1. And that's because its atomic number is the largest. And then the methyl group and this carbon here, these would be, if you want to call it this way, they would be the controversy because both of them are a carbon. So then what you've got to do is say, all right, what do we hit next? And over here, you're going to hit a hydrogen, and a hydrogen. Once we move away from the carbon. And on this one, it's a double bond, and we're going to an oxygen. So this carbon right here is going to win out over the methyl group. So it is going to be the second highest priority, and that makes this guy over here the third. Now, what I'm going to do is go ahead and just rotate this a little teeny bit. All I want to do is I want to make the hydrogen disappear. So I'm going to rewrite the carbon. My methyl group didn't really move. It rotated back and up just a pinch, and then here we're going to have, I'm just going to use the number. This is the priority number 2. And the Cl is going to come out of the board just a little bit. And so that's going to be group number 1. And this is group number 3. So then I just trace this out. And it's going counterclockwise. And since the lowest priority group is back by convention, this is the R configuration. Or, I mean, it's the S configuration, yeah. That's my dyslexia. My wife is always, when she tells me to turn left on the highway, I end up going right. All right. Okay, now this next one I switched around, so this one is for Shri, and probably others too. Yeah. It's going to be the carbon oxygen. That's going to take priority. All right, so we're going to have another single atom. Center, so this is going to be H. Okay, now the oxygen has, so again, this is the stereocenter. You can see right away the hydrogen is extending out of the board. So this guy is going to be a problem. That should tip you off right away. It's going to be like, all right, I have to be careful here because the lowest priority group's coming out of the plane of the board. All right, and so that means that you need to be thinking ahead. All right, how am I going to handle this? And then you can see off of the carbon we have an oxygen and we have a nitrogen. The oxygen has an atomic number of 8. The nitrogen has an atomic number of 7. So this is going to be the highest priority again, the oxygen, the hydroxyl group. And the amine is going to come in at number 2. And then the methyl group, the carbon having a lower atomic number than either the oxygen or the N, this is going to be group 3. All right, and then what I'm going to do, I keep this simple. Like back when I was a college student, for whatever reason, I think it wasn't until graduate school that I figured out this trick. I would rotate these suckers on paper, and I'm telling you right now, if you choose to do that, it's really easy to make a mistake. So I'm going to keep the H literally coming out of the plane of the board. So I'm going to rewrite the carbon over here. And then, the H won't be there now because literally it's coming out and hitting me in the face. And when I rotate this, I'm going to bring the molecule around this way a little bit like that. So the OH, or the OH is going to be like this. Because when I rotate the H around to the right, this is going to go this way. And this is going to come this way. So we're going to have the NH2 is going to be like that. And I don't know how to really show this here, but this is going to go in that way a little bit. So we're going to end up with the CH3 like this. And then this is number 1, 2, and 3. And then we scroll that way. So in terms of the scrolling, this would be S, but the object is upside down. So this is the R configuration. Oh, wait. Yeah. Sorry. Yeah. This is L wrong O. Yeah. So the arrow is going R. I told you guys I'm tired this morning. You better watch out. All right. So this is upside down. So this is the S. Yeah. Thank you. Yep. All right, so now I'm on a new screen. What happened? Oh, I just need my eyeball. Whoops. Why isn't it? There. Ah, there we go. All right. So I wanted to do at least one example with a ring. And examples that I've been drumming up, they come from a lot of sources, but the sources seem to favor things that are on the right side, so I decided to do this one on the left side. So now when you look at this, the stereo center is here. It's that carbon. All right, and this one I made it convenient. The H is going back into the plane of the board, so there's not much we have to do here with this except to validate where the second and third priority group is, because the O is going to take the priority again. Because as we move off of the carbon, we're coming to an oxygen here, and going in either of the other directions, we're hitting a carbon. So then we have to compare the left and the right carbons. And on this one, from the carbon, we have 3 different options. We hit a hydrogen, we hit another carbon, and we hit the iodine. Going the other way, here you're going to hit 2 H's. And then another carbon. So this guy over here, I want to change the color. This is going to take priority. This is group 2, and this is group 3. So now when we do the ring, one way to look at this, we're going to just rotate the molecule back. We don't have to take it back very far. So in other words, we're going to rotate it like that. The H is going to disappear because literally it's going to point straight back. And then both of these bonds are going to come out of the plane of the board. So we literally can to simplify this, we can do this. This is going to be group number 1. This is group number 2. And this is group number 3. And since the low priority is going back, we can scroll directly. So unless my dyslexic brain is flipping again, this is the S configuration. Does everyone agree on that? All right, so I'm going to stop the video now.